Hello everyone, in this video we will have a quick recapitulation of the chapter sets. First, coming to the definition of the sets, set is a well defined collection of distinct elements, means different elements. So, well defined, what do you mean by well defined? If you look at the set here A is equals to 1, 2, 3, it means when you speak about an element, the items or objects that are there in the set are called as elements. So, if you speak about an element, either it belongs to the set or it does not belong to the set. So, there will not be any confusion. It means it is a well defined set. So, well defined collection of distinct means different objects. It means no element will be repeated in a set, and the objects or items are called as elements in it. So, definition is a set is a well defined collection of distinct elements. Now, this symbol represents belongs to and does not belong. Coming to the naming convention of a set is represented using a capital letters. So, the name of the set is given like A, set B, set C. As you can see here in this example, set A is equals to 1, 2, 3. This A is the name of the set, and the elements in the set are represented in such a manner that they are placed inside these braces, and all the elements are separated by commas. Then we have various methods of representing these sets. The first being the roster form, or also called as tabular form. In this set, as you can see in this example, how is it placed? All the elements are listed out. So, this is in this we have the list of elements. All the elements are listed out and they are separated by commas. And if you, the main point that you have to observe is the order does not matter. So, as you can see here 1, 2, 3, 4, the same set can be written as 4, 1, 3, 2, anything. What matters is the same element should be there and the order does not matter. The first one was roster form. Then coming to the set builder form. What is set builder form? This is also a way of representing sets, and in this we do not list out the elements. What do we do then? We give the rule, just like if you can see this example, it is a set such that you read it as x such that x is an odd integer. X is an odd integer, like odd positive integer suppose. Then it will be like 1, 3, 5, 7 like that. So, in this what did we do? We did not list out the elements, we just gave the elements. We can have multiple examples like x such that x is a prime number, x such that x is a natural number. So, like that we have many ways, many sets that you can represent. Then we have Venn diagram. In this is the pictorial form of representing the sets. So, the main things that we have here is a rectangle and the circles. This rectangle represents the universal set. Universal set is nothing but a set which has all the elements in the that we are speaking about. So, it is denoted by mu, or this is mu symbol, and or capital U, and the sets are represented usually by circles, as you can see here. Then if you have the various operations we have on it, that is A union B. So, when you talk about A union B, this circle represents the set A and the circle represents the set B. So, A union B represents the set which has all the elements of both A and B. So, if at all he asks you to draw the to shade the portion which represents A union B, we have to do it like this, means complete circles should be shaded. Then if you represent, if you want to represent A intersection B, if you want to shade it, then this overlapping area represents the A intersection B. Now, coming to the third one, A minus B, the area which is the first set is A, this first set circle represents A and the second circle represents B. So, as you can see this shaded portion, we should not include this overlapped area. The area, this is, let me highlight. So, the area which is present here represents complete the circle. So, you should not include this overlapped portion. So, this area represents A minus B, and B minus A means the area here in this B set B excluding the overlapped portion, represents B minus A, this one. Now, coming to the various operations on the set. First, let us speak about the cardinality. What is cardinality? Cardinality is nothing but the number of elements in a set. So, if you say n of, if you are speaking about cardinality of the set, we represent it as n of A. It means the number of elements in a set. We just write the count of it. Suppose here in this set, as you can see, A is a set which has 3 elements, 1, 2, 3. So, cardinality of A, how do you write it? N of A is equals to, here n of A is equals to, we write n of A is equals to, how many elements are there here? 3. We just write the count. Then union means if two sets are given A and B, if you want to write the union, you have to write all the elements that are there in A and B, and the repeated elements should be written only once. By definition, the set has distinct elements. That is the reason we write, when you are writing A union B elements, we write only the repeated elements only once. Then intersection is the operation on the sets. If A and B are two sets, we write only the common elements in it. Then coming to the next one, difference. We have A minus B and B minus A. A minus B means, suppose if you are representing it as Venn diagram, the element that are present in this shaded portion will represent A minus B, set A minus B, and B minus A is the set which represents the elements which are there in the shaded portion as shown in the figure. Now, and one more thing that we need to observe is A minus B is not always equal to B minus A. Under only certain circumstances it will be equal, otherwise they will not be equal. Then coming to the next one, subset. Subset means, suppose if we have two sets A and B, then if all the elements of A are present in B, then we say that, and B may have extra elements as well. So, then A is said to be the subset of B. I repeat, if all the elements of A are there in set B and B may also have additional elements, then set A is said to be subset of B. Now, in the same case, because B has more elements, right, then we say that the same thing can also be said as B is superset of A. B is superset of A and A is subset of B. Now, if we ask us to write down the number of subset of a given set, a set may be given, and it may be asked that you need to write all the possible subsets. Then how many subsets do we get? If a set has n elements, then there will be 2 to the power of n subsets. How many subsets? 2 to the power of n subsets, right. Now, coming to the equal sets. Equal sets are the sets which have equal elements, equal number of elements, and also the faces of the elements will also be same, irrespective of the order. Then we have null set. Null set is a set which has no elements and it is a subset of every set. Null set is a subset of every set and a set is a subset of itself. So, if A is a set, then it is a subset of itself. The next thing is superset. Superset means if we talk about this A is superset of B, it means A has all the elements of B and it has additional elements other than what B has. So, we say that A has more elements than B and it also has all the elements of B. Then we say that A is superset of B. Now, there are different types of set. The first one is empty set. Empty set is nothing but a set which has no elements, a set which has no elements. The empty set is denoted by the symbol phi, or it can also be represented by the empty braces. Nothing should be written in any one of the ways you have to represent, either phi or empty braces. And people usually commit this mistake, they represent it in the wrong way, that is they place this phi inside these braces. So, this is the wrong method of representing empty set. Either it should be written just phi or just empty braces. Then coming to the next one, disjoint set. Disjoint sets are the sets which have nothing in common. If A and B are two sets, if they have no element that is common, then they are said to be disjoint set. So, if we find the intersection of those two sets A intersection B, because there is nothing common, so it will be a null set. Then we talk about finite and infinite set. Finite set is a set which has countable number of elements, whereas infinite set is a set which has uncountable number of elements. As you can see here, example, this set has 4 elements, 1, 2, 3, 4, we are able to count it. When it comes to here, n is a set which has, n is, what is n? N is a set of natural numbers. So, natural number starts from 1, 2, 3 and we do not have an ending point. So, these kind of sets are called as infinite sets. Let us do a quick recapitulation of the definitions of the sets. A set is a well defined collection of objects. All the elements in a set are distinct, it means not repeated. As you can see in this example, A is a set 1, 2, 3, 4, 5, we have the same set can also be written as 1, 5, 3, 2, 4. Okay. So, still they are same. What the difference is? Just the matter, which does not matter. Order. Name of the set is represented using capital letters, as we have done here using capital letter A. Now, representation of set is roster form, also called as tabular form. Elements will be listed in this method separated by commas and within the braces like this. Then set builder form we have. In this we give the rule for it, like x, such that x is a natural number less than 6. This is the way we write in set builder form. Then we have the another method, Venn diagram method. Venn diagram method. In this we use rectangles and circles to represent the sets. There are different types of sets, that is singleton set. A singleton set is a set with just one element. So, now is this, if we have a set suppose like this 2, is it a singleton set? Yes, because it has only one element. Now, is this a singleton set? It has an element 0. Yes, it is also a singleton set. Okay. So, 0 is also an element, right. So, this is also a singleton set. A set with one element is called as singleton set. Then null set or void set or empty set. It is a set with no elements. It is a set with no elements. Disjoint sets are the sets which have no common elements. If A and B are two sets, they have nothing in common. Okay. A and B are two sets, then they have nothing in common. So, when we represent in Venn diagram also, they do not overlap each other. They do not overlap each other. Such type of sets are called as disjoint sets. Infinite set and finite set. Finite sets are the sets with countable elements, whereas infinite sets are the sets with uncountable elements. Universal set is a collection of all elements including the elements outside the set. Suppose if we have some elements here 1, 2, 3, 4 and here 5. So, this universal set is a set which has all the elements 1, 2, 3, 4 and 5, all the elements of these sets and the elements which are there outside the set as well. Then equal sets, if all the elements of two sets are equal, in number and faces, means the number of elements are also same and the elements themselves are also same, then they are said to be equal sets. Cardinality of a set. If the number of elements in a set is equal, the cardinality is the number of elements in a set, or it is the count of the number of elements in the set. So, if A is a set, then suppose it has the elements 2, 3, 4, 5, 6, then the cardinality of the set A is 5. Coming to the subset, if A and B are two sets, then if all the elements of A are there in or contained in set B, then we say that A is a subset of B. That is, if A and B are two sets, then if all the elements of A are there in set B, then we say that A is a subset of B, and we represent it like this: A is subset of B. In the above, this set B is called as superset because it has the elements more than A and all the elements of A are also there in it. So, then we call the set B as the superset. So, if we need to shade the portion which represents A minus B, then this is the portion which represents A minus B, and this is the portion that represents B minus A, and A union B means all the elements of A and B together. So, we need to shade the entire two sets to A and B, and A intersection B is represented by the overlapping portion here.